just discussing just basically the task to discuss about digital workflows for infrastructure, and I'm just discussing a few of them. So this is just the agenda for this afternoon. What is infrastructure? What is a digital workflow for infrastructure? And then a few examples for the project that I work on. Rail projects, airport projects, wastewater projects, and for urban planning projects, and a simple summary to wrap it up. So just to start with, let's just discuss what is infrastructure first. So if you Google or you go to the dictionary, infrastructure refers to the basic physical and organizational structures needed for the operation of a society or a city or an enterprise. The term typically refers to structures that supports a society, like a road, a bridge, rails, water supply, sewers, electrical grids, telecommunication system, seaports, and airports, and so forth. And this is Bentley's definition of what infrastructure is. That they are actually, this particular company is actually, their BIM solution is actually geared towards infrastructure. And if you actually look, if you actually subdivide infrastructure, they're actually divided into two: hard infra and soft infra. And when you say hard infra, those are your MRT tunnels, your airports, flood control, electrical grids, and your soft infrastructure usually refers to hospitals, schools, community center, and so on. And you have to ask the question, why infrastructure is important? It is important because it's twice the lifespan as compared to building. So if a building is designed typically for 50 years, an infrastructure project is 100 years minimum. The capital outlay or investment is 3 times or 4 times bigger as compared to buildings. And it's considered an essential facility that cannot fail. You cannot close an infrastructure project. You cannot suspend it, or you cannot halt its operation. It's actually needed by the society. And the operation and maintenance cost, the O&M cost, is roughly about 70% of the lifespan cost of the building. So to build an infrastructure project is actually quite easy, but to operate it for the duration or the expected lifespan is the biggest issue to have. To put that into perspective, when you say BIM for buildings, the prime professional is normally the architect. That is followed by the engineers, structure, and MEP. But for infrastructure, you have the engineers, who is the prime professionals. They focus on the mechanical, electrical, plumbing, and then the structural elements of the building. And very, very small component is the architecture. Okay. Let's just say if you're building an MRT, you're just designing the spatial allocation, what room this particular area will have, and then what people and the signages may be, and that's all. Okay, so it's a small little component. The engineering part is a big component of infra. And when you say digital workflow, that's just basically information passing on from one data set to the next. Okay? If you actually talk about digital workflows for infrastructure, there's actually 2 main domain elements there. One is the project information model and the asset information model. So there is a big emphasis on the project information model that covers from your conceptual, preliminary, detailed design, all the way to your construction in as-built. And there is a big focus on asset information model because you have to maintain their structure. You have to operate this structure for a very long time as compared to buildings. This is a typical workflow for infrastructure. You have mapping, which is basically your GIS. You have your 3D models, which is talks about your BIM models. And you have documentation, which is basically your tender documentation. You have submission to authority, and then basically your documentation for the handover. And there are 3 different data sets that allows the transfer of information between GIS to models and to your documents. And that is actually captured, and this is actually the digital BIM strategy coming from the Crossrail Academy. Bentley is actually a big part of that Crossrail Academy in the UK when it was actually being formed. And then you can see there the differences between CAD GIS and models and so on, and what are their uses. Typical example of the big difference between buildings and infra is when it comes to file format. So as you know, if you are dealing with infrastructure projects that are basically horizontal in nature, there's one of them, which is land XML. It's actually shown here. The infrastructure model for that is actually saved in land XML. A competing standard would be CTGML, developed by the OGC, the Open Geospatial Consortium. So that is completely different from, let's just say, IFC. So if you talk about BIM for buildings, your neutral file format will most likely be IFC. But if you're talking about BIM for infrastructure project, most likely if it's a horizontal element, it will be land XML, or if it's a urban planning project or a master planning project, it would be CTGML. So there's a big difference between file formats. Another key point is CDE, or the Common Data Environment. So you must have, in this example, the CDE of choice is actually Oracle. Oracle, as you know, have a software called Econex, and Econex is a common data environment that you can actually import 3D models, GIS data, and so on and so forth. So this is what Crossrail has done. The Oracle Econex is similar to the Bentley's ProjectWise and so on, or the Autodesk BIM 360. It's basically the same. So just to give you a few examples of the rail digital workflow, this is the project I was working on before, the Kuala Lumpur-Singapore high-speed rail, and they have a BIM strategy similar to what's happened in Crossrail. And that BIM strategy is actually very simple. So there is a distinct difference between a project information model that is your preliminary, conceptual, you have detailed design all the way until construction. And then you have an asset information model that is used during operation and maintenance. And that particular set of information is actually captured in your documentation. You have the non-graphical data, that's basically your attributes or your properties, and you have your graphical model, which is basically either your solid geometry or your GIS data, which is actually represented in lines or on mesh. Okay. And to give an understanding of that, so this is typical. So for BIM for buildings, you have common services drawing or combined services drawing or CSD. But for models, it's completely different. So you're actually dealing with combined services model or CCSM. And that is actually created by the contractors. And that CCSM models is actually used for your 4D simulation. Okay. And they're actually upgraded, version up to become shop models. These are basically models that generates your fabrication drawings or your shop drawings. And this project information models become your as-built models. And the as-built models, if you populate it with 6D attributes, it becomes models fit for asset information models. So they are upgraded from a project information model, from design all the way until construction, and then they become asset information models. And in this case, it's actually termed as built asset models by the contractor, but it's given actually to the client. Another case in point is CDE, or Common Data Environment. For a small building, you can save your data in Google Drive or Dropbox or whatever. But for infrastructure project, you're dealing with very, very big models. So a common data environment is actually it's a necessity actually, because you're dealing with different types of models and so on. So this is, for example, a CDA setup that has maps, P6 schedules. It have commercial data models, 3D data models, and so on. And in the future, you have O&M data, you have environmental data, you have manufacturing data and construction data model to be put on at a later stage. Another one that I'd like to emphasize in digital workflows for infrastructure is your model production and delivery table. So it's basically just a simple Excel spreadsheet or a table that states, this is my 2D deliverable, this is my 3D deliverable, this is my 4D deliverable, and I am gonna deliver that at what date and time, and who is gonna be the model author of that. be the model user, and who's going to be the eventually that will keep that. For the projects that I've been working on before, this is a typical one on an infrastructure project, a rail project. There is a master model that is actually composed of 4 distinct data groups. The first one is your building. So you have substations, you have ventilation buildings. And then the other part is the civil component. That is basically your topography and so on. So you have digital terrain models, DTM, and so on. And you have viaduct, for example, for above ground structures that basically has your track and so on and so forth. And you have tunnels, which is your below ground structures. So these are 4 distinct data groups that is merged together or federated inside a master model. One interesting thing that we have actually visited, I have actually been, I'm not part of it, but I visited it after construction, was the Hallandsås tunnel in Sweden. In Sweden, it's the same story. You have a construction model, and the construction model is actually used to host drawings that is embedded inside the model or generated from the model directly. You have setting out data. Basically, these are GIS information. You have quantities extracted directly from the model itself. And you have visualization, obviously. That's your rendered images and so on. One interesting thing in Sweden is that they have distinct definition of your data groups or data drops, whatever you want to call it. You have construction model that has the technical field information. That's basically the existing condition. You have preconditions before the construction. You have landscape information and so on and so forth. You have system, that's your different systems, rail systems. And you have ongoing construction, that is your as constructed and as built model. In that particular project, the models are actually ranked higher than the drawings. So if there is a discrepancy between a model and a drawing, the model takes precedence. So they are basically higher. What we meant by that is that the model is the single source of truth. If you want to, if there's a difference between what is given as a 2D drawing or a 3D PDF, the model takes precedence for everything. The model is equally ranked as well as quantities. Reason being is that the quantities is actually generated directly from the model. So the BOQ elements is actually whatever is in the BOQ, how many cubic meter of soil to be extracted, or how many square meter of how to say the slab to be put in, is actually generated from the model itself. Okay. The other one is construction model in tender documents. In that particular project, there is no drawing that was given to the tenderers. What was given are actually 3D models. They're actually given as a 3D PDF at the time, and then they are actually, the tenderers actually use them to actually extract quantities and put their prices, the unit prices directly from those models. What is interesting is the use of 3D PDF. Before iModels, this is for this particular project, before iModels was actually created, long before, they actually just saved the file directly into 3D models. So a 3D PDF and an iModel and an IFC file are basically lightweight versions of your native models. So for tendering purposes, you are actually just giving the lightweight versions of your native files for your tenderers. This is another project that I was working on a long time ago. The Changi Airport Terminal 5 project. This is just a typical workflow. It's just basically saying that the consultants are actually submitting or uploading their work in progress models inside an EDMS, which is an electronic data management system, and they're actually saved on a CDE. So there's a distinct difference between EDMS and a CDE. In the current project that I'm working on, that is actually very, very, very clear. So an EDMS is just a portal where you actually upload models, and the actual workflow, who actually reviews it, who actually approves it, and who actually keeps it for future use, is inside the CDE, inside the common data environment. That is a big difference between a simple building project and an infrastructure project. You need to have a common data environment where you actually save and create a workflow to for approval process of your models. It's a typical one. Another workflows that we are actually using now. So if a contractor submit changes, or the client, or the owner's engineer, or the SO, supervising officer for government projects, actually initiated the change, what will happen and what procedure will be there for the project information model all the way to the asset information model. So a typical example for that is like this. So the owner's rep or the SO updates the virtual construction model, the work in progress model. The SO basically isolates the updated elements. They actually create a part 3D model instead of actually modifying the facility model. They're actually just creating a part 3D model, a small little portion of those particular change that you are actually conveying to the contractor. And then the contractor receives that and then incorporates it into the project information model that becomes the asset information model. So just a simple workflow. For the project, this is an urban planning project. Specifically, this is actually a particular workflow for the Jurong Innovation District that's actually beside NTU. This is a JTC project. So if you can see, we have transportation. So big data groups, transportation and infrastructure. And you have utilities, another big group, and then development parameters. So for example, for infrastructure and utilities, it's actually divided into wet, dry, and special facilities because they have specific components like the district logistic network. They have the combined services tunnel. You have the district cooling, and then you have the pneumatic waste conveyance system. So these are different systems that is unique to this particular project. What I'm trying to say is that for this particular project, there are 3 distinct data groups. You have 3D models in BIM. I'm talking about the rail, the roads, the bridges, the tunnel, the DLN, the combined services tunnel, the PWCS. And you have maps, which is your GIS model. So there are certain elements that is best represented as a map. Okay, so your parcels, your massing, your traffic, your corridor, your sewer lines, your drainage line, the water line, the new water line, the power and the telecom are best represented as maps instead of 3D geometry. And you have EXCO or existing conditions. So your LiDAR point clouds, you have your photogrammetric models, you have your digital terrain models. These are mostly saved as existing condition, which is a bit of a hybrid between a 3D model and a GIS surface data or maps. This is a typical workflow. That basically describes your preliminary model, pre-final model, and final model. So you're talking about how does your model development goes up from in terms of your road, your MRT lines, your wet infrastructure, your dry infrastructure, and your specialist infrastructure. So there are different different levels of detail for each type of element. So as a summary, I'm just saying that BIM for infrastructure is heavily biased on building services and structural discipline, and they're very small in architecture. So the prime professional in an infrastructure project are basically engineers. The second one is there's subtle differences between the project information model and an asset information model, and you have to carefully understood those differences. The PIM becomes the asset information model at the end, so you have to develop it nicely and with great care. And the third is the BIM and GIS integration to handle models and map will be clearly understood and anticipated. As mentioned before, there's a distinct difference between the models generated from BIM and then the surfaces, or feature definition that is found in GIS. They are complementing to each other. Most of the BIM software like Revit or EcoSim can handle both. Okay, so models and maps integration is very, very important. And then the fourth one is part 3D. Models can be used instead of creating facility models. every now and then because they're very, very big. You can actually deal with Part 3D models to actually handle your changes or your change management. And how you manage the federated models for infrastructure shall be clearly covered in your BIM execution plan. And those procedure or workflows needs to be enforced. You need somebody to enforce them. And then the last part that I'd like to convey is the importance of the CDE, the Common Data Environment, and the ADMS for information management. They are very, very critical and effective in digital workflows for infrastructure. That's all. Thanks.